All right. Hello, everyone. Hello. Yes, thank you. Okay, so my name is Tuukka Ahoniemi. It's also another weird name, and this time this name is from Finland. So I'm located in Finland. I also work in the product management with Nils. I too have a technical background. My background is actually in Qt training, so I'm officially certified Qt trainer, which is a pretty nice title, even outside the work, but in the bars and that stuff. But I've too been lately working with automotive. I'm also very much in the automotive industry in general. I drive a car every day, except today I took a cab, but that too is a car. Okay, so what we actually decided to do with Nils is when we went through these, the agenda for today is that we're pretty much going to be talking about the same stuff. But whereas Nils was more referring to the business aspect of items and like total cost of ownership of your automotive products and how the automotive industry is enabling new business opportunities, I'll be looking this more from the technical perspective. What does this all mean for software developers, and how do we solve these issues with Qt? Because that's a natural part of that very same equation, but maybe something slightly more graspable. So what we'll be going through today. So I'll be discussing more about the automotive systems, the IVI, infotainment systems. What are the requirements for them from the technical perspective? How does Qt solve those issues? And then about this general transition of creating automotive software, moving for more transparent systems where the power of ecosystem is more important. So we'll talk about how the Qt ecosystem actually helps in creating this transition of making automotive software in the future. Then we'll take a deeper look into the Qt GUI offering as maybe the most visible part of where Qt is being used inside the vehicle is in the infotainment system. So we'll look into how do you actually create these modern touch-based user experiences with Qt. What is it that we give you as our developer offering? And we'll talk a bit about Qt Quick, our technology, and we'll talk a bit about HTML5 and Qt Web Engine. How do you match these two together? And then at the end, we'll take a quick look onto the automotive specific APIs in Qt that are coming with the Qt Automotive Suite. So we have a lot of APIs for all kind of generic programming on desktop and embedded side, networking databases. Today we won't be actually touching them, but we'll focus slightly more only on the automotive aspects. And as a result, we kind of conclude on why Qt makes a lot of sense in the automotive side. So let's start with a statement, and this is pretty much summarizing where Neil started as well with that the automotive industry is changing a lot, and it's changing on way how users or customers or consumers buy or share cars. What is the criteria they use to select a car? These economical aspects, environmental aspects, technical aspects. But all in all, the conclusion that we take out from it is that software will more or less take over the form factor. The same thing that has happened with phones in the past 5 to 10 years is happening with cars. That instead of the physical form factor, the color, make, model, the engine, or the accessories of the car, the consumers actually select or make their purchasing decision based on what can I do with the car software-wise. What is the IVI system? What does it provide for me? For me, personally, it's very important that I have a Bluetooth connection to my phone and I'm able to extend my digital lifestyle to the situation where I'm sitting in my car as well. I can use my musical streaming services. I have my contacts there. It's actually a very important part of my personal criteria for car. And like Niels said, over half of the consumers today, or people purchasing cars, actually name the IVI system as the most important individual factor in the car. So when we talk about the user experience of the car, naturally it's still very important that, you know, it feels nice and the engine has enough torque, but it's also about the interface between yourself and the car, and that is more or less created with the software nowadays. So a well-functioning HMI is no longer a nice-to-have feature, but it's one of the essential part of the overall experience in the car. And if we turn this into requirements for the IVI systems from technical perspective, now Niels discussed the same item from business perspective, but from technical perspective, if we look at the situation today, where we have a huge amount of custom hardware and we have a huge amount of different software platforms that can be used for building those IVI systems. Those can come from OEMs, or those can be like proprietary solutions of tier ones. But everyone more or less have their own kind of a frameworks on top of frameworks. And for the person who is actually supposed to create the software on top of these, it creates an interesting situation. How do I do something that can expand to all of these devices at the same time, but then on the other hand leverage all the possibilities for each of those individual platforms? So more or less today it's a wild west of technologies out there. And there are these consortiums and movements like Genevieve and automotive grade Linux that are actually trying to harmonize this situation, and they're moving greatly, and we're happy and proud to be part of those movements. But today the situation is far from harmonious, standardized technical offerings. So what is required from an IVI system? Well, you need to have a lot of flexibility. The same IVI systems are going to be used in various kinds of car makes and models, and also for different kind of setups. Some of the cars can have Bluetooth connection to the phone, some of them can have a satellite radio, or some of them only have an FM radio. But what you don't want to do is that you would do an IVI system, a separate IVI system for all of these different setups. But instead you want to make an IVI system that is somehow plug-in based, and based on the actual hardware that's on the device and the accessories, you dynamically select the contents. I mean, this means, of course, talking to the hardware through the APIs, but it also affects how does the user interface that work. That also needs to be plug-in based. That whether I show this item on the menu, I bet it must be rather frustrating for a consumer to have a Bluetooth screen on his IVI system without having the actual Bluetooth. So that thing must be removed from the user interface of those cars that do not have that accessory. Okay, then the car industry is very global. So when you make a car, you can actually, or an IVI system, you should expect that it's used all around the world. And that, of course, brings a requirement for internationalization and localization. So those things, of course, need to be implicitly built in as flexibly as possible to the IVI system. What your end users are expecting, besides having the modern interface that's very similar to their phones and tablets, is of course that everything runs fluently. 60 FPS, no delays at all. And usually this is an interesting situation for the software developer, that on the other hand I have this hardware that has its own limitations, but then on the other hand I have these requirements for a futuristic UI with all these 3D effects and animations. How do I make these work? So there's a lot of work for us to do also in the software side for getting a good performance out of the IVI system. Multitasking is also something that's needed, and then fast boot up time or preloading. We actually had I think it was, that was probably like already 5 years ago. There was a customer case where we had to basically just improve the boot up time of the IVI system dramatically. I mean, this is a very typical common bottleneck for many of the automotive IVI systems, that you have like a hard requirement for, I don't know, 1.5 seconds to have everything up and running on the screen. So if you start loading your Linux kernel and all the rich UI stuff and multimedia elements after the car has started, it's gonna be a quite tricky situation. So quite often what you do is, when the user unlocks the door, you already at that point, you start preloading some of the components like the Linux there, or you never shut it down until the end user or the driver really has left the car for like 30 seconds or so. And the other things you do is you do this like lazy loading mechanism, that you only load the first elements on the screen quickly, and then on the background you start loading the other elements. So, but again, thinking this from software perspective, these are more dimensions of complexity that are being introduced to our daily work. And then the multi-screen challenge. This of course adds a nice set of extra features as well, or extra requirements. So instead of just one screen on the car, we also have the instrument cluster, and a good and modern instrument cluster actually today shows you like the navigation as well, like your next navigation hints. It might show you what song you're playing. It tells you who's calling on your phone. So basically the instrument cluster is very much connected to what's happening on the IVI screen. And then you might have a head-up display that's again controlled by another CPU maybe with more limited graphics, but still connected. And you might have backseat infotainment systems, and bring your own device. You might be able to connect arbitrary mobile phones like iOS phones, Android phones or tablets to the same system as well. And that introduces another aspect of security, but that's another topic as well. So the requirements for these software systems as such have dramatically exploded. You're no longer making a single device with one screen, you're making a whole system of different multiple screens. Okay, so essentially we are no longer building just these self-contained embedded screens, but the cars have more or less become or became full-blown software platforms. So the users expect to get all the content that's relevant for them to the car. And you're supposed to build a platform for that content. And a platform is only as good as the content of that platform. So the question is, how do you get good content? Well, you need to have good developer offering. You need to get developers to work for the content. And on the other hand, for those developers, you want to provide a lucrative way to bring in or import their software that they have built for other platforms to the content. So it must be easy for the developer to create new content, but it also needs to be lucrative for the developer so that he doesn't need to do a new version for your car, but he can just actually use the product that he has already made for mobile phones or tablets or TVs, and then the car is just one extra platform which doesn't necessarily require any modifications to the software he has written. Okay, a good example of this kind of platformitization is from one of our customers from, I think we started working with them already in 2012 or 2011. So what they had done was a very proprietary windowing system and graphics stack on top of their hardware. And they had already worked for this for a couple of years, and it was performing quite nicely. It was very optimized for their GPU setup, so they were able to do their own car graphics and the user interface for that setup very easily. But then all out of sudden, they realized that it's very difficult to get any external applications for this setup, because basically their own windowing system was so low level because it was optimized, and it was also very proprietary that it was very difficult for them to convince external developers to take up on the task and build something on top of their system. So then at that point we started working with them, not just providing Qt, but we actually had consultants working over at their premises. And what we ended up doing is we ported Qt on their hardware platform as a parallel developer offering for external developers. So already at that point, even though they wanted to replace everything with Qt, it was too late to start writing everything from the scratch. So at the end product, at the car, they actually have two different rendering surfaces. The other one is made with their own proprietary items, and those ones are like the car's own menus and these kind of items. And then there's a separate rendering surface for Qt built items, which are basically all the applications that are running on the platform. So they had this kind of a very weird hybrid combination. But then what they quite soon realized is that in the next program that they started, they wrote everything from the scratch using Qt, and they already kind of got this platform for not only for internal but also for external developers to work on. So Qt is a cross-platform framework, and kind of what we want to tell our, let's say, application developers, the people who are building like music services or music streaming services with Qt or you know, any kind of visualization applications or mobile games or whatever apps. We want to tell them that with Qt you can actually create platform independent software services. That you do not need to prioritize between your platforms, but you just write them with Qt using the one code base or at least one technology, and the application will run as is on mobile, desktop, and on embedded platforms as well. Okay, nowadays, currently, it's mostly desktop and mobile where they're running these apps, but when more and more of these cars will actually support Qt even for external developers to have applications on them, like the smart TVs, for instance, already have today. The same way, these Qt developers can immediately access those automotive markets as well with their existing software. So in a way, they're also future-proofing their applications with Qt, not only for just new operating system versions, but also for new platforms like cars, which will in the future run the software they have already written. Okay, let's get back to the multi-screen challenge and kind of combine this aspect with the cross-platform functionality. So within the car, we have all these different screens. We have the IVI system, instrument cluster, head-up display, backseat infotainment, and the bring your own device kind of a approach with the iPhones, iPads, Android devices, Windows phones, whatever. So even when you're writing to internal applications of the car, with Qt, you can still use the same technology and just kind of create a separate presentation layer of that IVI system data and all the functionality there with something called Qt Quick. So Qt Quick is, well, I'll talk about that soon, but Qt Quick is a combination of a presentation layer written with something called QML, which is a declarative UI language, and then the C++ backend. So what it does is that it separates the high-level presentation of the user interface from the actual logic of the application. And this allows you to create easily different kinds of presentations for different screens, all showing the same system. And you can reuse a lot of the code between those different screens as well, but naturally your instrument cluster will look quite different than your IVI system. And if you're gonna write a mobile app to access that IVI system, probably that will look slightly different as well. So you want to rewrite them, but at least you're doing them with same technology, and you don't need to write separate applications, for instance, for iPhones and iPads and for Android devices. Underneath the presentation layer, underneath the UI layer, we also provide a lot of APIs for accessing the hardware, accessing the devices or the kind of different systems within the car, and building your application logic itself. So naturally we have all these networking, database, data structure, these kind of APIs. But for automotive, we have, for instance, the CAN bus implementation for serial bus. So you get Qt APIs, you get high-level APIs for accessing the CAN bus to talk to the different parts of the automotive system. All right. Besides IVI systems, let's talk a bit about how the whole software process within the automotive industry is changing. So more or less, what we're seeing is that the industry is moving away from this black box creation, black box system creation, to a more transparent white box creation. So instead of everyone reinventing the wheel, or the IVI system, the industry players, more or less, they do not only want to work together. I'm not even sure how much they want to work together with each other, but they want to work together with the content creators and the software side of industry to get new content and to get validated and verified kind of a quality content and more flexibility for using that content and those software stacks in different kinds of setups. So again, the other problem that this one of these cases I mentioned earlier, another problem that they had was that when they had created this proprietary windowing system and they had spent 2 years working for that project, when they wanted to change the hardware, it was actually quite impractical. So what they had to do is they actually had to ditch all the hardware-specific code they had built for 2 years and rewrite all those items again for the next hardware. And that was only that hardware as well. So then again, they would have had to do the same item for all the different hardware setups they had. And that's a very unbearable situation. That has no flexibility at all. So the black box model clearly does not work. But you want to have a transparent stack of technologies in your portfolio. And what are the requirements for this kind of transparency? Well, first of all, we've noticed that the build systems, they play a major role. Most of the problems there seem to be are very much related to problems around build systems, not necessarily porting Qt or part of the software, but more like getting things properly built and getting a workflow that allows developers to be productive. And especially when you try to change hardware or items of the middleware, if you have an inflexible build system, that's something that will definitely highlight all the issues you have. Then when you are starting to accept contributions from others, or you want to open your code base for the open source community, or even for other partners under NDA, you need to have some sort of a working contribution model. You need to have it in practical level, so there needs to be a way for people to submit patches and for other people to review the patches. And then you need to have this, the contribution model working also licensing-wise. So when people contribute patches, how does the licensing and the legal aspects of these contributions work? And as you're sharing code, apparently you need to have common coding styles. Other people will need to start reading your code. You need to have some sort of a harmonious commenting way or documentation way of the code, and most likely in a language that other people can read as well, especially if you're doing anything outside your own country. So here we get to the very important aspect of kind of a modern platform creation, that when you're making a platform, what you need is a very well-functioning ecosystem around your technology. So what the ecosystem can do for you is that the ecosystem actually can do a lot of the maintenance work of the infrastructure. It can provide a lot of new code in terms of contributions, but it can also validate a lot of the existing code, and most importantly, the ecosystem will give you developers. So like I said before, a platform is only as good as the content in it, and for getting the content you need developers. So it's actually today, it's very difficult. I don't know how is it in Korea, but at least in Finland and in US, it's very difficult to find embedded software developers. And just generic embedded software developers that are very good in C++. But even that is difficult, but when you start looking for embedded C++ developers who are very good, who also have knowledge from automotive industry, I think that's a very near impossible task. So what you need from your platform and the ecosystem is you need to get these people who already have the knowledge of the technology that you're using. They don't necessarily need to have the knowledge of your industry. I mean, that's always a benefit, but that they can learn as they're working. But the technical aspect is something that at least today is very difficult to find. And that's where we get to the Qt ecosystem. So as Qt has been around for over 20 years, and our main purpose has been in being a cross-platform software framework, that means we have for the past 20 years, the Qt ecosystem has worked in porting Qt into all different kinds of hardware and operating system and middleware setups. So actually we have these 20 years of silent knowledge in how to get your build systems in place, how to have well-functioning and flexible build systems, because that's what we do with Qt every day when we are porting Qt to all these different real-time operating systems, all these new embedded development boards, also outside the automotive industry. But okay, we're also working a lot with the automotive industry players, so we're doing the same work for the automotive platforms at the same time. Another thing that we have in place is the open source contribution model. So we already have the Qt project in place. So we are already running all the infrastructure for getting these contributions to the platform. In addition to that, Qt itself is a rather mature technology. So it's not something we reinvent with every release, but it's something that we already have millions of developers using, and it matures slightly, but of course we avoid doing any dramatic changes. So it's there, it's a very stable foundation for creating software, as so many people are dependent on that, and we've already polished most of the problems, most of the kind of the biggest problems around it over these years. We have good documentation, examples, all these tutorials in place, and we have a lot of companies and also a lot of technology partners, and even companies that have built their business on top of Qt. So there's a huge ecosystem, also a huge commercial ecosystem around Qt. And most importantly, we have around 1 million developers that already know how to build software for the automotive platform as they are using Qt. So one of my friends who is actually working as our principal automotive consultants nowadays. He started working with mobile, or actually before mobile he was doing desktop Qt for the KDE project, and then when he got to our company he was working on mobile projects. And now all of a sudden he's working for the automotive industry. And he's still very good at what he does because he knows Qt that well, and the technology more or less is the same, and just the platform differences or industry differences change from project to project. Okay, this was actually one of the examples he was working himself like pretty much like 2 to 4 months ago. So we had a customer case where we wanted to port Qt for the Renesas R-Car platform, and the customer already had their own legacy build system. And kind of what we found out is that most of the time that we spent with the project went to fixing the build system. So getting Qt running on that platform was very simple after we got the build system fixed. So usually the biggest problems in porting Qt to a new platform are related to things outside Qt. But once those are fixed, and we, like I said, we have a lot of knowledge on these build systems and getting Qt-based build systems work on different platforms, we were able to fix them. But getting Qt itself to that platform, that was actually just a simple EGLFS implementation. So basically just connecting the graphical parts of Qt and the actual system. And as a nice side effect, as the Renesas R-Car uses this general KMS or the kernel mode setting API, the same stack more or less runs on the Intel platforms as well. So we were able to run the same stack on a PC. And that's pretty nice because you can actually do a lot of the development with Qt now running on your desktop and immediately deploy it there. I mean, of course, Qt itself runs on desktop as well, but now the whole stack was running on the desktop. So we were able to kind of do rapid deployment and rapid development of that same project on a desktop environment without actually needing to have access to the board all the time. Okay, here's a small disclaimer. You want to test your application on the real hardware as soon as possible. So you don't necessarily want to you don't want to stick on the desktop side for too long. Okay, then after we had done the Renesas R-Car item, what we did is that we ported the same stack to the NVIDIA Jetson Pro. We already had Qt running on the Jetson TK1, which is a more generic embedded board. So now we took it to the Jetson Pro, which is the automotive platform. And this one uses the same KMS API than Renesas port. So that thing was easy, but the buffering mechanism was different. So this was actually altogether 1 week of work from one consultant to port Qt on this different hardware. And what we kind of can conclude pretty much from this is that, okay, Qt gives you a wide hardware support out of the box, but it's also very easy to port and customize the stack for other hardware. And especially in the automotive world, this is rather unique. There are often hundreds of people working just for the software stack, whereas with Qt, we can handle this stuff with a handful of developers. And when you turn this into numbers, I mean, it's very easy to realize that what is more effective. Okay, let's talk a bit about the UI side. So when we talk about the IVI systems, the importance of the user experience cannot be highlighted enough. The end users clearly expect the best possible modern user experience with full performance. And as Qt itself is a native framework, So we always run on top of the native services directly. We are really pushing the full native performance, and we are, for instance, the Qt Quick itself runs on OpenGL. So we're really optimizing how OpenGL is used underneath and optimizing the call order of the OpenGL commands. This is something really essential for us. Quite often you also need your own windowing system, and we provide our own Wayland API for creating your own compositor. We did some measurements compared to Weston. The Qt compositor, or the Wayland-based Qt compositor, was actually 30% more performant than Weston. So we are pretty good at providing the full performance on this side. So how do you then actually create automotive GUIs with Qt? What do we give for the developers? So we have this technology called Qt Quick. There are many ways for doing UIs in Qt, but Qt Quick is clearly the modern one for doing any touch-based UIs. I mentioned this before, but Qt Quick separates the declarative UI representation from the imperative C++ logic. And this gives you nice flexibility in doing multi-screen development, but it also gives you a nice designer-developer workflow. So the designers can actually directly work on the QML side, writing the UI presentation, and then the developers, they can focus on the application logic, or they can work together with the designers on the same end product. So the designers do not need to create a separate mock-up that the developers then need to imitate. That's not very flexible. I actually have a small use case about that too. But the designer and developer can work together with the same end output. Besides that, we fully support touchscreens and all kinds of touch gestures that's built into Qt. There's a lot of there's an existing collection of a lot of UI controls, so all these kind of buttons and gauges, and you can easily customize them to your own look and feel. Animations, transitions, or 3D effects, they're very easy to add into Qt. Like I said, it all works on top of OpenGL, so you can directly do, for instance, OpenGL shaders to your UI, or you can integrate 3D graphics. And like Lars introduced, we're actually going to have a couple of different ways for integrating 3D graphics in the future releases of Qt with our own 3D engine as well. A localization is also built into Qt and the user interfaces, so you don't need to manually create a mechanism for that. Let's take a small example of. So one of the customers we have been working on the IVI side, their existing workflow had their designers working on a completely different technology. And what they did is that they did a mock-up of the IVI system running on an iPad. So the designers worked on the design, and then they created something beautiful on the iPad. And then the iPad was given to the developers, and of course, people testing it. And the developers looked at the screen and, okay, let's imitate this with our technology. And, well, you can clearly see that this is not a very easy way to do rapid. I wouldn't say it's rapid development. So it took them 6 weeks to implement each change in the design. And of course, when you test the item in the car, then you quite soon realize that, okay, this doesn't work, this needs to be changed, and again, back to drawing board. So what we did with them is we changed the whole workflow to a Qt Quick-based one, where the designers were actually working directly with Qt Quick. So what this allows you to do is that you can immediately, when you change the design, you can just immediately deploy it to the actual platform, and you see the changes there. It's not a matter of weeks, it's not even a matter of days or hours, it's immediate. And more or less what we want to do here is we want to provide the same kind of agility for embedded and automotive development that software developers and software industry has already getting used to in, for instance, web development or mobile development. Agile development and rapid prototyping are de facto ways of working in those industries. So why here in automotive, why are we stuck with something like this, like 6 weeks? Well, we're not anymore. Okay, a few words about HTML5. So Qt and HTML5 are not mutually exclusive. There are a lot of valid reasons why someone wants to use HTML5 or needs to use HTML5, but like Nils explained, for HTML5 you need some sort of a solution. You need an engine to run that HTML5 dynamic contents there. And we actually provide a browser engine. We provide something called Qt Web Engine. And Qt Web Engine is basically a convenient port of the Chromium project. So it's a port of Chromium for Qt. And as it's Qt, it's cross-platform, but it's also deeply integrated into the Qt graphics stack. So you can directly mix and match your HTML5 contents with Qt Quick UIs. You can apply the same OpenGL shaders to your HTML5 contents, and you can interact with the HTML5 contents. It's not a separate world, it's inside the Qt world. So what we kind of have noticed when working with customers on the HTML5 side is, well, HTML5 is not designed for GUI creation. It has a lot of these inconveniences and the performance has some problems, but like I said, there are a lot of use cases for HTML5. So what we more or less recommend or encourage is this kind of a hybrid approach where you build everything you can using Qt Quick. So you do all your GUI controls and kind of all the native stuff there with Qt Quick, and then you use HTML5 for the dynamic items where you need to use HTML5, and you mix and match these freely. And with HTML5, you really want to start testing in real hardware as soon as possible. We've had a lot of cases where where the customer has done everything first on desktop side, and then when they have ported things to the embedded hardware, the performance is just unbearable. And that's usually the case. So you want to run it on the hardware as early as possible, and kind of in order to get a realistic view of the performance. Then there are, even within Qt, we had the old Qt WebKit, and then there are other solutions also. Our experience quite clearly says that please select Qt Web Engine as your browser engine and do it from the start. Do it immediately. It's just so much more functioning and so much better than the others. And okay, we get a lot of consultancy hours from people not doing this, but it's not a win-win situation. So Qt Web Engine is a nice starting point. Okay, Nils showed this quickly, the contents of the Qt Automotive Suite. So again, I kind of slightly want to highlight that Qt and Qt Automotive Suite are not the same things. Qt itself can be used and has been used in automotive for a long time. An Automotive Suite is something we have built on top of Qt to make it even more simpler to create automotive systems using Qt. So you get Qt Quick, you get Qt Web Engine, you get all this stuff from Qt itself, but what we are providing with Automotive Suite is a set of tools that are really good for automotive, a set of specific automotive APIs, an application manager that Nils showed you that actually can handle all these different applications, the built-in applications, third-party applications, your whole user interface, the communication mechanism, and all in a secure way. It's a big part of the things you need to write when you're doing an IVI system. So now you kind of get that infrastructure built in. And then underneath, we're also providing the middleware and porting for Linux and also for other platforms and for these automotive specific embedded platforms. A quick look to some of these automotive APIs. So the Qt Speech API is something that we will introduce as a technology preview with Qt 5.6 in probably at the end of next year. At the beginning of next year in January. And Qt Speech will include voice to text and text to voice. And for automotive, the important part is in the speech recognition API. So there will be an API for speech recognition, and for the open source offering, it will use the Pocket Sphinx as its engine. And for the commercial side, we have actually plugged this in with the Nuance Vocon speech recognition engine. Qt Serial Bus is a generic API that can be used with all kinds of buses, but for the automotive, we will introduce a CAN bus implementation. The CAN bus implementation will actually support socket CAN, peak CAN, and tiny CAN already at this point. Then we are providing a full virtual keyboard solution that, for instance, does handwrite recognition. It supports multiple different languages, also left to right text. It's fully customizable. You can plug in word prediction engines. Again, this is something you would need to implement yourself if you would start doing this from scratch. So it's kind of something that we've done for you. It's a very generic and important component. Then the state chart XML item is something also in the works. So SCXML, this thing here, is a format for defining state charts. And state charts and state machines are a very typical way for defining UIs and also how the application behaves. So the SCXML is going to be something that will plug in to Qt so that you can define your UI states in the SCXML format. You can edit the SCXML on a visual editor inside Qt Creator, and then you can directly compile that into C++ or even dynamically change the state machines of your application. Yeah, I think those are pretty much the most important items. Let's do a short summary. So, more or less, what I wanted to emphasize here is that from the legacy of Qt, we really much polished the whole idea of keeping your kind of application and the top level items separate and platform independent from the hardware and from the native components. So actually let's look at this slide. So with Qt itself, we provide platform independent ways for doing a lot of the items inside the car and also on these different devices, for instance your phones and tablets. And now with the automotive suite, we're also adding more automotive relevant items such as the CAN bus items, audio handling, screen composition, over-the-air updates. I didn't actually even talk about OTA, but that's something we're also planning for the automotive suite, that there's an infrastructure for you to upgrade the software on your car on the fly. That's pretty important as well. Okay, I think we have pretty much reached the end of my time slot. So I guess at this point I'll say thank you, and I'm happy to take some questions after the session in the lobby if you want to. So, thanks.